चैनल को लाइक करें और सब्सक्राइब करें ताकि आपको सभी इंपॉर्टेंट अपडेट्स टाइमली मिल सके. Subscribe the channel now. Okay, welcome all in this new session. We will start with work and energy. This is one of the 11th chapter of class 9th. Let us begin. This is from physics section and we are going to start today. That is work and energy. We'll try to complete this topic today itself so that you will have ample amount of time for revision purpose. So let us start. So the name of the chapter is work and energy. This chapter is divided into two parts. First top part will be focusing on work itself and another rest of the part will be focusing on energy. So there are two types and two parts on which this particular lesson is divided into. So the first part we are looking into is work. So let us start with work. In work, what exactly is work? Like what are the types of the work? And that is the first thing we want to know. So there are two types of work we can do. One is called as mental work. Like like suppose let's say if you study for 5 to 6 hours, so you might say that you have done some work, right? We always say after studying some time we say that we have done some work. That is mental work. So you have not changed your position. What you have done is basically you have just you were sitting at one position and you were studying. So study is nothing but a mental kind of work. Study. Doing study is nothing but that is the best example for mental work. What about physical work? For example, you are playing cricket. Okay, that is the best physical work you can do. So let's say you are playing cricket and you are applying some force. Suppose let's say you are using your bat, you are hitting the ball, okay, and you are getting suppose 4 or 6. So that playing cricket is the best example of physical work in which you are playing using the bat and you are hitting the ball. The ball is after applying force, it is moving from one place to another. So that is playing cricket is one of the best examples you can have for physical work. Now, according to scientific definition, this cannot be termed as work. Okay, mental work cannot be said as a kind of work in scientific definition. So in scientific definition, only physical work is taken into account. So you have to remember one thing. For scientific definitions, this particular mental work kind of thing, it doesn't work. There is no such thing as mental work for scientific points. In terms of scientific point of view, only this work is said to be actual work. This is not work. This is the work we are talking about. So only physical work is considered. That is the first thing you should understand. So mental work is not there. Only physical work is counted in terms of scientific definitions. Now the next thing we want to focus is, can we say that the work is done? Like, when we can say that work is done. So the first criteria that you can use that when can we really say that the work is done? The first criteria is if the force is acted, suppose let's say on an object. If some kind of force is acting on an object and that object should move from one place to another. We'll take our cricket example. For example, suppose let's say, or we will just take some football example. See, if this is the ground, this is you, and there is one ball in front of you. Okay, there is one ball in front of you, that is this one. Let us take a green ball. Okay, so let's say this is your ball, and if you are hitting this ball, you are applying some force on it. You are applying some force on it. Let us just say you are applying some force on it, that is F. And because of that, that ball moves from one place to another. That ball has moved from this A position to B position, for example. That is the displacement. So this is the displacement what it felt. This is the displacement. So in this case, you can say that you have performed some work on the ball. So what in this case you are saying? You have done work on whom? On the ball. Are you understanding this? That we can say that force is acting on some object only if what should be the main criteria for this? The main criteria which you can use for identifying or saying that whether the work is done or not. The first thing is force should be applied on some object. There should always be some kind of force which is applied. And because of the force, some kind of displacement should be created in the object. Some kind of displacement should also be created in the object. Only then you can say the work is done on some object. Understood? So if you have applied some force and there is no displacement at all, then you are going to say the work done is 0. So when can we say work is done? When force is applied and due to that displacement has taken place. So what can be the formula for this? The formula for work done is work is equal to force applied, force into, and the displacement which is occurring, that is force into displacement. Okay, this is the formula. So that means if force is 0, then also work is 0. If displacement is not, suppose let's say not there, that means if the object is not moving from one place to another, there is 0 displacement. Also then the work is 0. So the basic formula is work is equal to force into displacement. Force into displacement. Force is represented by F and displacement is represented by S. So this is the formula, that is work is equal to force into displacement. So let us just have some, let's say, definition for this. So this is the concept we are looking at. If there is one brick which is kept on a table, and if you are applying some force and it has created displacement from, so let's say the object has moved from position A to position B. The displacement that occurred was S. Then force can be given by, in this case, the work done can be given by work is equal to force into displacement. Work is equal to force into displacement. Are you understanding this? So work is equal to force into displacement. That is what it is given, and you are supposed to use dot. Okay, that dot also means multiplication itself. So for lower grade, it doesn't matter whether you are putting a cross there or dot there. But in higher grades, it does matter because you are trying to show whether it's a cross product or dot product. But for right now, you do not have to worry. You just put a dot there. It is more than sufficient. Basically, it means multiplication. For higher grades, this representation will change. But for now, you can just remember this, because even for higher grades, you will be given another formula, that is for work, and that is Fs cos theta. Okay, Fs cos theta. That is actually another formula you can use, that is the cos function of the angle between force and displacement. So that you can use, but right now you don't have to focus, because in terms of class 9, it is not required. So you can just remember this formula and you can forget about the bottom one. Okay, now let us try to understand. Suppose let's say then what can be the definition for work, like what kind of definition we can put. So the definition you can put is this: work is said to be done, work is said to be done on an object when an object faces displacement. Suppose let's say displacement occurs in that object, and that due to the application of the force which was done on it, due to the application of force on it. So work is said to be done when an object faces displacement, या फिर displacement occurs in the object due to the application of force on it. So this is the most basic definition you can use in your exam also. Okay, now moving on, this is just the work definition. So you just have to understand that if force is applied on an object and if it moves from one place to another, then it is called as work is done on that object. That's it. Okay, now what can be the unit of this? See, the formula for work is force into displacement, right? Okay, and what is the unit of force? Unit of force is Newton. And what is the unit of displacement? Displacement unit is meter, right? So the formula will become Newton meter, right? The unit that will be Newton meter. But Newton meter can be represented by another unit also, and that another unit is called as joule. That another unit is called as joule. So you have to remember there are two units. Basically, right now till now, we have gone through two units of work. First is Newton meter, that we have received from the formula. We have changed a force to Newton, and suppose let's say the unit of force is Newton and the unit of displacement is meter. So we have received Newton meter. Now Newton meter has another representation. It is also called as joule. And there is another point which is, suppose let's say, used. This is SI unit. SI unit of work is joule. But what is the CGS unit? CGS unit of work is erg. And what is the relation between joule and erg? Like for example, SI unit of force is Newton, and what is the CGS unit of force? That is dyne. And what is the relation between the two? 1 Newton is equal to 10 to the power 5 times. Correct? Okay. In the same way, you have relation between 1 joule and erg, and that is 1 joule is equal to 10 to the power 7 ergs. Okay? I hope you are understanding this. Is a very simple concept. That SI unit is nothing but joule, and CGS unit of that is erg. And the relation between both of them is 1 joule is equal to 10 to the power 7 ergs. Now let us talk about the example. Like for example, can we really calculate what can be the force applied? So this is just a common example which is given in our textbook, solved example. We are just talking about it. So in this case, there is one brick, the same brick which was kept on the table. I hope you remember this, the example which we had taken for understanding this one, right? Okay, so the same brick they have taken, and they are saying the applied force is 5 Newton, and they are saying ki the displacement in this case was 2 meter. They are asking us to calculate the force. Now force in this case, they are asking us to calculate work. So work can be found out by force into displacement, that is F into S. What is force? That is 5 Newton, which is given here, and into displacement is 2. So the answer would be 10 joules, right? The answer would be 10 joules in this case. So you can see the answer can either be written as Newton meter, or the correct representation can also be set as joule. So either you write down Newton meter or either you write down joule. But my suggestion would be to use a standard format now, that is joule. Forget about that Newton meter. That is good for only competitive examination, wherein suppose they're asking the same thing in the objective questions like what is the unit of work. Then you can choose from multiple options. But while you are writing down some numerical and all, try to collect the habit now to write down the original unit as joule instead of Newton meter, right? Even though it is correct, but still use joule, okay? Because that is the standard SI unit for work, so we are supposed to use that often. Now let us talk about types of work. Now there are types of work, like for example there is positive work, there is negative work, and there is zero work. Zero work, there is no need, suppose let us say, to talk about zero work, okay? Because we can easily find it out. Force is nothing but is equal to work is equal to force into displacement, right? Okay. Now you tell me, what do you mean by zero work? Zero work is nothing but when work is zero, and when work can become zero. Work can become zero if the applied force doesn't create any displacement. That means you are applying force and the object is not moving at all. Now you might think, where can this position arise wherein the displacement is zero? Suppose there is a huge rock. There is a huge rock and you are trying to move it. Suppose let's say from one place to another. So you are here. You are applying force. Okay, you are applying force with both of your hand, both your legs. You are trying to push, but the object is not moving at all. Now, is it true that you are not applying force? No, that is wrong, because you were trying to apply force, right? But the object was not moving. So what you are going to say is you were applying some force. Let us just say you were applying 50 Newton of force, and still the object was not moving. So you can take 50 Newton in the formula, but the displacement, it was not moving at all. So displacement is zero. The object has not moved an inch from the position. So you can just say displacement is zero. So that means S is zero. And what would be the answer? 50 into 0 is 0. So that means works become zero if the displacement is 0. Understood? So zero work, if the applied force doesn't create any displacement, then that is called as zero work. What about positive and negative work? See, this happens only if, let us talk about positive work. So if the force and displacement are in the same direction, for example, like this example, like the brick which was told to us, this one, right? Now the force applied was in this direction. Let us just say this is east direction, right? This is east direction. Now force is towards the east direction. Force is towards the east direction. What about displacement? Displacement is also towards the east direction. You can see that object has moved from position A to B. Basically, it has moved towards the east direction only. So displacement is also having what direction? East direction only. So can I say both of them have the same direction? In this case, as both are, suppose it's in the same direction, even if you want to give notation, like for example, if we consider force as positive, right, in the right direction, east direction, then displacement will also be positive in this case. So that's why, as both suppose force and displacement are positive, positive force and positive displacement, work done will also be positive. That is positive value of some joule, because forces and displacement are the same direction, so they have the same polarity. That means basically the same, we exactly cannot say polarity, but exactly what we can say is they have the same, either they are positive or either they are negative. Both have the same signs, basically convention wise. So in this case the work will be positive. So you have to understand that the work will be positive only if force and displacement are in the same direction, they're acting in the same direction. Now what happens if the force and displacement, they are completely happening in opposite direction? That means there is an angle of 180 degree almost, like they are moving in the opposite direction. Now you might think, where can this position arise? Like, where can this kind of thing happen? Like, what is the main criteria? A simple example for this is the cars. Cars is the best example for it. Let me just give you one simple example. See, this is the car, right? Okay. Now, if suppose let's say this is moving, okay, this is moving, and suddenly this moving car, because of there was some obstacle in the road, you are trying to apply brakes. Now, after applying brakes, the force is in this direction. Correct? Can I say like this? The force will be in the west direction. Correct? Because and why we are saying this is west direction? Because we are using the standard so let's say direction. That means up is north, okay? Down is south, right is towards the east, and so let's say left is towards the west. So we are using the standard format of geography. In the same way, we are applying the same logic here. So you are applying force. The force is being applied on the car. So let's say the tires of the car, and we are trying to stop it, right? But still, you must have seen that even after applying brakes, the car doesn't stop immediately. It is still continuing to move. It will still continue to move ahead. So that means displacement is happening in the which direction? East direction. Displacement is happening in the east direction, while the force which you applied was in the backward direction. So this is the brake position, right? So applying brakes in the car, applying brakes, right? This is the position we are talking about. Okay. So in the east direction, what is there? Displacement. Displacement is happening in the east direction. And what about west direction? Force is being applied. That is the brake force, right? Force. And in bracket you can write down brake force. That means force due to brakes. Okay, brake force will be like, you will again get confused what is brake force. So instead of that, you write down force due to brake. Force due to brake you can use, right? Okay, so this is the point you can use. Definitely you can go for it. Okay, so the logic is very simple, that the displacement is happening in the east direction while the force is being applied in the west direction. So both have opposite directions, right? So suppose if displacement is given positive, so let us assume for a second that displacement is given positive, because let us just apply the logic of x-axis, y-axis. For example, this is given positive direction, because this side we are saying that this is positive on x-axis and this is negative on x-axis, right? If we are just considering this is x-axis kind of position, so displacement is having positive direction, and then force will have what kind of direction? Negative direction. That means in the opposite way, right? So this is having negative position. That is the logic you are supposed to use in this case also. So when we are trying to calculate work in this case, it would be force into displacement. But according to your information, displacement is positive. So that is positive displacement. And force in this case is negative as per your information, because it is acting in the opposite direction. So you can just write it down there, negative, negative. And then what happens between multiplication between minus and positive? The answer would be negative. Multiplication between negative and positive is always negative. So the answer in this case, the work done in this case will be negative. Right? So negative work doesn't mean like, something like we always try to say that person is positive, this person is negative. It is not that kind of logic. What we are trying to say basically with negative is that force and displacement, they have opposite direction. Force and displacement have opposite direction. That is what we want to say. And when the work is positive, that means both have the same direction. Which two are having the same direction? Force and displacement will have the same direction. So that is the logic behind types of work, that is positive, negative, and zero work. Right? So let us go for, we have seen the positive work, so there is no issue. Negative work we have seen. Now let us talk about this one. That is the example, simple example which is given in our textbook. Example number 11.2. They are saying a porter lifts a luggage of 15 kg from the ground and puts it on his head 1.5 above the ground. Okay? So he has taken some luggage which is around 15 kg or so, and he has taken that particular so let's say the luggage, and he has kept it above its head. From the ground he has lifted, and from the ground, the distance between the ground and the head of that person is around 1.5. Right? They are asking us to calculate the work done. Chalo, so let us try to understand this. So if this is the mass of that particular object, now for work done, the formula is force into displacement. Correct? But force is not given here. No force is given. But force formula, we know. What is the formula for force? That is mass into acceleration. So you can use mass into acceleration into that displacement which is there. Okay, so we have written force, we have divided into two parts. Correct? Okay, and displacement as it is. Displacement has been taken as it is. Okay. What about the next part? Do we have acceleration? We have mass, right? In the question, we have mass, so this is mass. We have mass, no issue. Displacement also we have. What don't we have is acceleration. But you have taken this, like, because of the ground you have taken, right? Because of the ground you have taken. So that means in this case, due to that ground, the acceleration due to gravity will be acting on that particular object. So you cannot use acceleration in this case. The thing which you need to use is acceleration due to gravity. So again, I need to modify this formula. M will be written as M, S will be written as S, but A will be written as G, acceleration due to gravity. Are you understanding this? Okay. Now you are supposed to understand that for unless and until it is stated, you can take for in the book the value of g has been taken. You can see it is taken as 10, right? So you can also take 10 because 9.8 and 10 is almost equal, right? 9.8 is almost equal to 10. So for calculation purpose, you can take it 10 so that the calculations will become easier, because with 9.8 it is decimal, it will be very hard for your calculations, right? Okay. So the calculation would be, what is the value of g in this case? G in this case is 10 meter per second square. It is exactly 9.8, but you can take 10 for easier calculation. So I am taking 10. So I can replace all the values and I can find out the answer. But you have to understand one thing. They have done the same thing, right? They have taken, like, mass is 15. So we are putting 15. What about G? That is 10. So we have put 10 and into S. Displacement. What is the displacement? That is 1.5. So you can multiply 1.5. But you have to understand one thing, that the object was taken from the ground. And because of that, the value of G should be taken positive or negative? Negative in this case. So you have to understand there is one mistake in the book. You have to understand that and you have to correct it. In the book, they have taken directly positive, but it cannot be taken positive. It has to be taken negative. Why? Because the object was taken from the ground. So gravitational force is downside. Object you are taking, like, you are moving it up. So the value of G should be taken negative. And what would be the answer now? You can just multiply 15. This 15 will remain as 15 and this minus sign, and 10 into 1.5 is 15, right? Okay, so 15 into 15 is 225. And what about the negative sign? That will remain as it is, and the answer would be joules. Okay, are you understanding in this case how to suppose calculate the answers? Okay, I hope you are understanding this. Okay, you just have to modify the value of g has to be taken in negative terms, and the answer would be minus 225 joules. So that correction you can make in your textbook, and then we can move ahead, right? Okay. Now talking about energy, we have talked about work done, like what is the formula, what are its units, CJS unit, SI unit, and we have seen some examples on it also. Now we are going for the next point, and that is about energy. Now, what is energy basically? The energy is the capacity to do the work. Energy is what? The capacity to do the work. So sometimes, suppose, let us say, if you are, suppose, let's say, playing some game. For example, we'll take the same example. We are playing cricket, for example, right? So you are doing a lot of work. You are doing physical exertion. You are hitting the ball. The ball is moving. Displacement is happening. So work is being done, right? Okay. But what about energy? Is energy required to play the game? Obviously, without energy, you cannot do the work. And hence, for work to be done, like for example, the game you are playing, what is required for playing cricket? Energy is required, right? Okay. That's why the definition is given as energy is the capacity to do the work. This is the definition you can use in your exam. Energy is the capacity to do the work. Now, as energy and work, they are almost same. You can see that is just the capacity to do the work. So these physical quantities are all like almost same. So the unit for both of them is same. The unit for work is joule. The unit of energy is also joule. The unit of CJS unit of work is erg. In the same way, energy will also have the same CJS unit, that is erg. And what is the relation between the two? The relation is 1 joule is equal to 10 to the power 7 ergs. Okay, so the same we have the same units for work and energy. They do not change. Now question is, can we change suppose let's say energy from one form to another? So definitely we can change. So let's say there are lots of energies, forms of energies. So you must have heard about light energy, you must have heard about chemical energy, heat energy. Heat energy you must have understood, like you must have heard electrical energy, that is already available at your home. So electrical energy, this light energy, this type tube light. And there is one more term called as potential energy, kinetic energy, which is a combination of basically mechanical energy. So we are going to talk about them in detail. Particularly, we don't have this in syllabus. The other energies, we only have this in syllabus: kinetic energy in detail and potential energy in detail, and a minor definition of mechanical energy. We do not have too much of detail about mechanical energy. Also, that is just the basics we have. But potential energy and kinetic energy has been dealt in detail with their derivation formulas, and numericals also are based on the same energies also. So these energies, these are just for example I have told you, but these are not there in our syllabus. This is not to be taught in detail. So that is not there. Now let us talk about kinetic energy first. I told you two energies are going to be discussed in too much of detail. The first one is kinetic energy and the second one is potential energy. Now what is kinetic energy? So you must have heard this word in your 7th grade during the chapter. Suppose let's say heat. They must have told you there is conduction, convection, then radiation, and they must have told you that suppose let's say particles of a substance, they constantly move, and that is what they have is kinetic energy. So kinetic energy is nothing but energy due to the motion of the body. You have to understand this definition you can use. Kinetic energy is the energy possessed by an object due to motion. In short, you can say energy due to motion is kinetic energy. Energy, you can use even this definition which I am writing up. Energy due to motion is called as kinetic energy. It's so simple. Energy due to motion is called kinetic energy. Right? So you can use this definition even for your exams. Energy due to motion is called as kinetic energy. That's it. After this, other definition what we have is kinetic energy of a body moving with a certain velocity is equal to the work done on it to make it acquire that velocity. Other definition which we can give or let's say use in the exam is kinetic energy of a body moving with a certain velocity is equal to the work done on it to acquire that velocity. So it is just equal to the work done which is used to acquire that velocity, and that velocity is due to that work done is called as kinetic energy. So this is somewhat complicated, but in shorter form if I want to represent this, they want to say kinetic energy is nothing but equal to work done. In shorter so let's say representation, if I want to show that in mathematical terms, this is what they want to say, that kinetic energy is equal to work done, and work done to acquire that particular velocity, right? Okay, so that is the definition you can use, but I would suggest to use the upper definition, that energy due to motion is called kinetic energy, because that is so small, simple and easy to remember. Energy due to motion, that's it. Okay, now let us talk about derivation of kinetic energy. Okay. Now what we are going to do is we are going to derive let's say kinetic energy formula. Now to derive the kinetic energy formula, the first thing we are going to require is we are going to solve this with the help of the formula of work done. Now work is equals to force into displacement, right? That is the first formula you're going to have. Now force can be written as mass into acceleration into displacement, right? This is the formula we are going to have. Now let us talk about what is the formula for the third equation of motion. Now third equation of motion can be represented as v square minus u square is equal to 2s, right? V square minus u square is equal to 2s. Now what if I want to have the value of the original formula, what we want to know from this particular thing is about kinetic energy. Okay. Now what we can do in this case, we have to derive the formula for kinetic energy. You can so let's say find the value of s from this equation. The value will become v square minus u square divided by 2a, right? That would be equals to s. Now same thing you can shift into this particular formula. M into what is the value of a? A you can just keep as it is. S you can change as v square minus u square and divided by 2a. So you can cancel both of them. You can cancel, suppose let us say this A and this A, and what you will get is mass into V square minus U square divided by 2. That is the value you are going to get. So you can just rearrange them. So what you will get is half, this half, 2 has been shifted to the left hand side. Then you will have M, and in bracket you will have V square minus U square. This is the formula you are going to get. Okay. So what you're getting is basically force into displacement. Then you have substituted the value of S from the equation, right? And you have received half m v square minus u square. But what if the object is stationary? If the object is stationary, that the object is not moving at all. Initially it was not moving, but after some time it is moving with some certain velocity. So if the object was at rest at initial position, then u becomes 0, right? If object at rest initially, okay? If the object was at rest initially, then what will happen? So u is equal to 0. Now what kind of change that will bring to the formula? The formula will become something like this. The formula will become w is equals to half m in bracket v square minus 0 square, and that will become w is equal to half m v square. There is no reason to write down that 0 because 0 square is nothing but 0. So the equation will become w is equal to half m v square. But just before some time we have seen that kinetic energy is equals to work done, right? Okay. In the same way, then you can write it down there that W is nothing but you can represent that by energy. Energy is equal to half mv square, and as this energy belongs to kinetic energy, you can put a k there. You can put a k there just to represent that this energy belongs to kinetic energy. Or otherwise, you can just write down this formula also in terms of that. You can write down ke is equal to half mv square. That is also you can put it. Fine. Okay, so now let us try to understand the same thing from the equation. So what we have done is, in the exam what you have to do is, first write down the third equation of motion, v square minus u square 2s, then find out the value of s from that, then you can write down the formula for work, that is force into displacement. F can be represented as m into a into s. Value of s is this, you can put it here, and it will become m into a into v square minus u square divided by 2, right? A and A will get cancelled, and what will become is half m v square minus u square. That will be your answer, final answer. And that's it. The object, if it is at rest, then you will get w is equal to half mv square. And after that, you can just represent that work done and kinetic energy is same. So hence, Ek would be equals to half mv square. Correct? So that is the derivation you have seen right now for kinetic energy. Now let us try to find out answer for this. The question is, an object of mass 15 kg, so this is the mass, is moving with a uniform velocity of 4 meter per second. So velocity is 4 meter per second. They are asking what is the kinetic energy. Now that is so simple. Write down the given data first. What is the mass? That is 15 kg. And what about V? V is 4 meter per second. Now what is the kinetic energy? Kinetic energy is equals to half mv square. Half into what is the mass? That is 15. What about v square? V square means what? 4 square. 4 square will be how much? 16. Okay, so you can just multiply. So that is 1 by 2 into 15 into 4 square is 16. But 2 ones are 2 8s are 16. 15 8s are 15 8s is 120. So the answer would be 120 joules. So kinetic energy is 120 joules. Okay, very simple formula. You just have to apply the formula, that is half mv square. Put the values there and you will get your answer. Correct? And the answer should be, the unit should be written at the end, and that is joule. Now let us talk about what is the work done to increase the velocity of a car from 30 to 60 km per hour if the mass of the car is 1500 kg. So we can just find out the work done, that is not a problem. But to find out the work, we need this. In this work, this is basically in terms of velocity. So even if we find out kinetic energy, the answer would be same. But to find out kinetic energy, we need half mv square. That means we require the velocity. Now what we'll do is, we will use the original formula of kinetic energy. That is half mv square, right? But it is originally, what is the formula? That is v square minus u square. Because you know for a fact that, suppose let's say this formula we received. This is actually your original formula. If I want to highlight like what is the original formula, this is your original formula. Which one? This is your original formula. Basically, that means kinetic energy is equal to half m v square minus u square. That is your original formula. It becomes half mv square only if the object is at rest. So, if two velocities are given, like in this case, you can use the original formula, that is ek is equal to half m v square minus u square. Now, you can try to find out value of v and u, convert this into meter per second first, and then you can solve the question. So, mass is already given, that is 1500. So, you can put it up half into 1500. What about V and U? That has not been shown, right? So this is V and this is U. So you can just first convert them. The value would be, so let's say the difference as such. So you can just convert them first, or you can suppose let's say take the value of V square minus U square and then you can divide it if you want. But I would suggest to convert them first itself. So the answer would be, this is 30 km per hour. Let us convert this, that is 30 into 5 by 18. Basically, kilometers has to be converted to meters, that is 1000 meters, and hour has to be converted to seconds basically. So 1 minute has 60 seconds and 60 minutes will be having how many seconds? 3600. Okay, you can just divide them. So two zeros has been cancelled, two zeros has been cancelled. Then again, suppose let's say this is 300 and divided by 36. You can divide by 4. That is the best option you can go for. So 4 nines are 36, and yeah, okay, 5 is fine. Or either you can just suppose let's say go with some shorter numbers if you want. That is totally up to you. So what is remaining is 300 divided by 36. So 3 ones are 3, that is 100, and 3 ones are 3 twos are. Then you can divide by 4, because suppose let's say if higher numbers you are not able to do the calculations, so you can just divide by 3 and then you can divide by 4. That is up to you. How the kind of calculations you want to do, that is totally up to you. Now you can divide by 4, that is 425 is 100 and 4 3s are 12, so answer is 25 by 3. What about V? V is 60 km per hour, right? It can also be converted into meter per second, and this is 1000 again divided by 360. Now the answer would be, so two zeros are cancelled. So 1 0 is cancelled from here and 1 from here. 1 0 is cancelled from here and here. So what is remaining is 300 divided by again 36. Right? But it is not 30, it is 60. Sorry, I took it 30 from the top hand side. So that is 60 itself. So that is 600. Okay, now let us try to divide this. So, okay, so this time we'll divide by 4. So that will become easy. 4 ones are 4, 220, 4 5s are 20, 0, and 4 9s are 36. 3 3s are 9, 3 5s are 15, and 0. So that is 50 by 3. 50 by 3 is, that is what you are getting. Now you can just put the values there and you can find out the answer. But you can solve them separately also, and then you can put. Fine. Okay. So I am solving this particular v square minus u square here, and then I will put the value in terms of the question. So v square minus u square is equal to 25 by 3, 25 by 3 square minus 50 by 3 bracket square. Okay, this is your calculation. Now after this is a square minus b square. So you can do a plus b, a minus b. That is the best thing you can do. Or otherwise you can just simply square it. That is totally up to you. Fine. Whether you want to square it or not. Okay, I think I have written that v value and u value interchanged. Okay, interchangeably I have done that. V value is 50 by 3. Sorry about that. I thought it is 25 by 3. So that is 50 by 3 and that is 25 by 3. So if you are not comfortable, you can directly take the square of it. 50 square is 5 5s are 25, double 0. What is the square of 3? That is 9. What about this 3? That is also 9. What about 25 the square? 625. So the calculation will be 2500 divided by 9. 9 will be same. And you can just subtract 2500 minus 625. 2500 minus 625. So 10 minus 5 is 5. 10 minus 3 is 7. This is 4 and this is 1. So 14 minus 6. That will be how much? 14 minus 6. That is 4 and 4, 8. So basically it's 1875. So 1875 divided by 9. So you can put the value there. the answer would be 1875 divided by 9. So you can do this calculation now. So 3 3s are 9, 3 5s are 15, 0 0. So that is 500 now. So if you divide by 2, that will be 2 2s are 4, 110, 5s are 250. Now that is 250 into 1875 divided by 3. Okay? Okay, so what we are going to do now is, for the remaining calculation, you can just multiply them. 250 into 1875. You can take 0 as it is, and you can multiply 25 into 5 is 125. So 5 and 12 carry. Then 25 sevens are, that would be, suppose let's say 175 and the previous 12. So that is around 7, right? Okay, so that would be 7. And then the rest 25 are 200, and then that would be around um, 46, right? 468750. Correct? Okay, so till this time, the final calculation would be 468750. Let me just calculate it again. 25 5s are correct, 8s are 200, and carry, and yes, correct. So you can just divide it now. So the final answer would be 3 1s are 3, then 1 bacha 16, 3 5s are 15, 1 18, 3 6 are 18, 3 2s are 6, 1 15, 3 5s are 15, and 0. So the final answer would be 156250, and the answer would be joules. Right. Okay. So this is your calculation. So either you can, suppose let us say, use this formula, or you can even use the book formula. Like in the book, what they have done is, they have calculated initial kinetic energy separately, final kinetic energy separately, and then they have subtracted it. So you can do in this way also, or either you can use directly the formula which I have told. I think this formula would be better. That means just combine them. But if you are not comfortable with combining the formulas, you can solve it individually like these, which are shown in the book. First find out the initial kinetic energy, then find out final kinetic energy, and then subtract them. Right? The subtraction would be your answer. So that is up to you how you have to calculate, but I would suggest to use the combined formula. Right? Now let us go for the next one. Now till now, we have seen energy that is called as kinetic energy, which is due to motion. But there is also one another energy in play, and that is called as potential energy. Now potential energy is something very unique, very important, and potential energy is due to what? It is due to configuration or position. So for example, like if you stretch a bow, this is stretching of the bow. If you stretch a bow like this, like you take the arrow back, and there will be lot of energy which is, suppose let's say, accumulated in the string. Correct? Lot of energy is accumulated in the string. So this is due to the configuration. This is due to the configuration. Configuration means what? Configuration means the way it is. Suppose let us say, in this situation, like due to the position, you can say, or suppose let's say, due to the situation which is arising. So in this case, due to, as you are stretching the bow, the stretched wire is having lot of energy, and that same energy, after you release, that will be transferred to that arrow, and then we'll be able to shoot that arrow, right? So this stretched, so let's say the thread is having one kind of energy, and that is due to configuration, and that is called as potential energy. So in this case, it is due to configuration, due to its weight, right? So this is called as potential energy. There is another same kind of energy is also due to position also. Potential energy also exists due to position also. Like for example, this is a dam. Water is falling, right? Now water falls from a great height. The water which is at a great height from the ground, the position is very much above at the elevated position, like it is an elevated level. During such situation, when some object is kept at a height, it also has some energy. It has lot of energy, because when this water falls down, the same energy is converted into afterwards electrical energy. Afterwards, we are converting into electrical energy. So initially, that energy is potential due to its height. So you have to understand the initial energy is potential energy, and after that we convert it into electrical. In between, it also converts to kinetic energy, but we are not concerned about it right now. We just want to know where does the potential energy exist. So either it can exist in configuration like this, like the stretched bow or a string, and even in clocks, for example, the older clocks which were not the digital ones, the older kind of, the spring kind of ones. So in those also potential energy is there. Another one what we have is dam. Even in dams, so let's say the water is kept at a very much a higher level, and that is also called as potential energy. So what kind of definition we can put forth for potential energy? Because for kinetic energy, we had said that kinetic energy is due to motion. Energy due to motion is kinetic energy. For potential energy, what we are going to say is the energy possessed by the object due to its position or configuration. Due to its position or configuration. In that kinetic energy, we had said it's due to motion. In this case, we are going to say due to its position or configuration. Then we are going to say it is called as potential energy. So this definition you can use in the exam also. Potential energy is the energy possessed by the object due to its position or configuration. Now, what about suppose let's say the derivation of this? So derivation is quite simple for in this case because the formula and all those things are already given. So if suppose let's say if there is some object like this, so let's say this is the object, and if we are taking it to a higher level, for example, let me just draw one ground. So this is our ground, this is our box, and this box we have taken to this height. We have taken this box to this height, that is h. Now in this case, how we can find out suppose let's say potential energy. So first we have to find out work done, because energy is nothing but work done. So later on we can convert work to potential energy. So first we are going to find out work done in this case. So that is force into displacement, right? Force into displacement. But force in this case is mass into acceleration into s. But in this case, the acceleration is due to gravity. So you are going to write down m into g into s. But you also know one another fact that displacement in this case is height. This is the displacement. The object is moving from one place to another. So in this case, displacement is represented by letter h. So in the formula also you are going to write down h. So work done is the formula is mgh. If we combine them, it is mgh. But you also know that work done and energy are same. So potential energy would be equals to work done. So in the same way, suppose let's say we are going to write down energy and work done is same. Correct? Energy and work done are same. But work done has been found out as mgh. So we can say this is potential energy. So potential energy would be equals to mgh. The formula would become mgh. So it's a very simple derivation. What we have, that work is equal to force into displacement, then mass into acceleration. Force you can change, displacement is s can be represented as h because displacement is nothing but height in this case, and then you can write down the formula work is equal to mgh, and then you can just close it because potential energy is nothing but work. So ep, that is potential energy, is equal to mgh. The same thing is also given in the book. You can see potential energy is equal to mgh. So in the exam, either they will ask you the derivation of so let's say potential energy or the derivation of the kinetic energy. Potential energy derivation is quite simple. Kinetic energy, you need to revise it at least once or twice, or at least practice it. Only then you will be able to write it down in the exam. Okay, now let us talk about if suppose there are two paths. For example, we are taking two objects. One object is moving from position A to position B, and in this case also it is moving from position A to position B. But in this case, the path taken was path 1, and in this case, it was taken path 2. So you can see in this case, the object was taken straight forward up from A to B. It was straightforward, in a straight way it was taken. Now in this case, it was first taken to the top, then it was taken towards the right, then again it was taken towards the top, then again it was taken towards the right. Sorry, that means left. In this case it was right, now it is left, and again it was taken towards the top. Question is whether the work will be different for both of them. Actually, if you are really trying to find out if the potential energy is going to be same, or suppose let's say the work done in this case is going to be same or not, we will just try to find it out. See, work done in this case is force into displacement. Work done in this case is also force into displacement. Now force, your applied force, for example, if it is F, the way it has been taken up, and the applied force in this case is also F, for example. In this case, what is the height? You can see the height in this case is H. So work done is equal to F into H. What about this case? Even if you have two paths, but you are not supposed to focus on that. You first need to just tell us what is the height. And what is the height in this case? It is the same one as the original one, the first case. The height in this case is also H. Hence, what you are going to write down this is in this case also the answer would be F into H. Work done is equal to force into displacement. Displacement in this case is also H, even though the path was quite different from path 1. So as both the formulas are same, you can see here both the formulas are same, this one and this one. Okay, so that's why what you're going to say is, as these both formulas are same, you are going to say that work done, suppose let's say it depends on height. Work done depends on height and not on the path along which the object has moved. So it doesn't depend on the path, it just depends on the height. That is what you need to remember. Fine. Okay. Now let us talk about, suppose let's say this question. Find the energy possessed by an object if the mass is 10 kg. It is at a height of 6 meters above the ground. So they are just asking us to calculate kinetic energy. So kinetic energy can easily be found out, or potential energy. In this case, all we have to find out is, suppose we are supposed to find out what is the energy in this case. Now they are never going to tell you what kind of energy they want to find out. For example, they might say that they want kinetic energy or they want potential energy. They are not going to specify. We have to find it for ourselves whether they are talking about potential energy or whether they are talking about kinetic energy. How can we find out? If the velocity is given, if the object of whatever the is given in the question, if they have given some kind of velocity for that, then we have to find out kinetic energy. If they have not given velocity, then what we have to find out? Potential energy. It is as simple as that. Now in this question, no velocity is given, so you can directly write down. But we have to find out which energy then? Potential energy. As kinetic energy, no velocity is given, so we have to find out potential energy in this case. Now what is the formula? Potential energy formula is very simple. Let me just write it down. The formula is potential energy is equal to m into g into h, mgh, right? Now what is the mass which is given? That is 10. Mass given is 10. What is the g which is given? It is given in the question, that is 9.8. So if in the question it is given 9.8, then you have to take it 9.8. Otherwise you can take it 10. Correct? And what is the height? What is the height in this case? The height in this case is 6 meters. So you can put the value there, 6. Now 98 into 10 is 98. 9.8 into 10 is 98 into 6. You can just multiply and you will get your answer. 6 8s are 48. 4 carry. 9 6s are 54. 54 plus 4, 58. So basically your answer is going to be 588 joules. Right? In this case which we have found out. In the same way the answer is 588 joules. So you can see the same thing has been done in the book also. Right? So we have calculated the answer from the question. EP is equal to mgh, the formula, put the values and you will get your answer. Now let us talk about this question. In this question they have said a mass of 12 kg, that means it is mass, is at a certain height above the ground. If the potential energy is 480 joules, find the height at which the object was taken with respect to the ground. So in this case now they are asking us to find out height. Okay, so we can easily find that out, no issue. But first we will write down the information which is given. Mass is 12 kg. Then potential energy is given as energy, that is potential is given as 480 joules. Height we have to find out, and G value they are asking us to take is at 10. Now what is the formula for this thing? Potential energy. Potential energy is equal to mgh, right? They are asking us to find out height, so height is equal to EP divided by mg. What is the value of EP? That means potential energy, that is 480. And what about m? Mass. Mass of the particular object is 12 kg. And what is the value of g? That is 10. Right? 0 and 0 are cancelled. You can just cancel out 0 and 0. So 12 ones are 12 twos are 24, 12 threes are 36, 12 fours are 48. So basically h is equals to 4. Your answer will be 4. And what should be the unit we should use? The standard SI unit for height is, for displacement is basically meters. So the answer in this case would be 4 meters. Right? So in this case, potential energy was given. We were supposed to find out the height. Very simple. You just have to use the same formula and put the values. Now the next question we are going to deal with is, are various energy forms interconvertible? So this is the very bigger question we are going to face today, that can we convert energy from one form to another? Definitely you can convert. You can just simply take example from your home. Suppose let's say you must be having some kind of electric bulb at your home. It converts which energy to which energy? It converts electrical energy to which energy? It converts electrical energy into light energy, right? Okay. Suppose let's say, do you know? Suppose let's say the speaker what you have at your home. Speaker. It converts what energy to what energy? It converts electrical energy to sound energy. Are you understanding this? Speakers convert electrical energy to sound energy. Electrical energy to sound energy. And what about microphones? That is, suppose let's say you must have seen in the some functions at your schools. Some like guests are coming. They are giving speeches. The speech is given with the help of microphone. They speak in the microphone, and that is transmitted to the sound, right, to the wires. So microphone, it converts basically sound. Our speech, it is converting from sound energy to which energy? Sound energy to electrical energy. Those electrical signals pass through the wires to the sound itself. So speaker basically. So sound energy is getting converted to electrical energy. What about dynamo? Dynamo is generally available in your cycles. You must be having some cycles in which there is no battery, nothing, but still there is one bulb which is given, which glows once you paddle, right? So you're basically, the bulb which you have on your bicycle, it is working because of your bicycling, right? So basically the device which is there on your bicycle is dynamo. It is converted in your mechanical energy, your muscular energy, your muscular energy to basically which energy? What kind of energy? Electrical energy. So basically you are converting mechanical energy to electrical energy. So as you can see, there are lots of conversion. You can even take the example of tubes, CFLs, even fan. So there are lots of devices what we have in which we are able to convert one energy to another energy. So answer is very simple for this question. Are various energy forms interconvertible? Yes, those are interconvertible. We can definitely change the energy levels. Now the examples what you need to use is these ones. In the exam, you can use electrical bulb, speaker, or you can take lot of a big list from your home itself. Just think over the devices. See, you are, suppose let's say, living in your home for many years. You know what kind of devices are there. You just close your eyes, imagine, suppose let's say, the kind of devices you have at your home, and just write down their names, and that will be sufficient. That will be more than sufficient for your particular answer in the exam. Now, that is fine. So we have understood that energies can be converted from one form to another. Now there is another law which you want to study, and that is law of conservation of energy. Now this is a very important law, very universal law. It says that energy can only be created from one form to another. Energy can be converted from one form to another, so that we know it can be converted from one form to another. It can neither be created nor destroyed. We cannot create energy, we cannot destroy energy, we can only convert it. And the total energy before and after the transformation remains the same. That means they are saying the total energy in the universe remains constant. So we can neither create the energy, neither destroy the energy, we can just convert it from one form to another. And the energy before the conversion and after the conversion remains same. So these are the three statements you need to write down in the exam. In place of the third statement, even if you write total energy in the universe remains same, that is also the same statement which is there for this particular law. So you can write down the third statement as, if you are feeling that this is somewhat hard, the third statement, you can write down total energy in the universe remains constant. This particular statement you can also use. Total energy in the universe remains constant. Right? So we have completed law of conservation of energy also. So now let us talk about energy conversion. Right? We are talking about energy conversion. Now how exactly the energy is getting converted from one form to another. Now imagine a situation when, suppose let's say there is an object, suppose let's say there is a ball at the height h from the ground. This is your ground. This, the height from that, suppose let's say, object is, that ball is h. The height in this case is h. Okay. Now we just have to find out how the energy is getting converted. After that ball is falling down, and the final position is this. This is the final position. This is the initial position. Okay, so let me just write down the names there. So this is final initial position. Okay, so this is the initial position and this is the final position. Okay. Now, this is initial position and this is final position. Now, let us try to understand what kind of energy levels they will have at the upper side and lower side. So, the object is falling down. Okay. Now, let us try to understand what would be the kinetic energy and what would be the potential energy. Now, the potential energy in this case would be potential energy would be equals to mgh, right? Mgh, because the object is at height. So, the answer would be mgh. What would be the kinetic energy? The kinetic energy in this case would be 0. Why? Because the object is not moving. Initially, it would be at rest. The object, so let's say we have released the object from the height, the initial energy would be 0, right? So, hence, the total kinetic energy would be 0 because the velocity is 0. So let's say the initial velocity is 0, so kinetic energy would be 0. Now, what about the bottom part? If you're talking about the bottom part, the potential energy in this case would be 0. Why? Because the formula is mgh. When it comes to the, suppose let's say to the ground, the height becomes 0. The height becomes 0, so the total calculation would be 0 itself. What about kinetic energy? It would be half mv square. Okay, so what I will do is, instead of writing down 0 here, I will write down the complete explanation, that is half mv square, and as the velocity has 0 value, the calculation will become 0. So in this case, kinetic energy is 0, potential energy is mgh. So can I say, and what is the total energy? Total energy in this case would be potential energy plus kinetic energy, correct? Okay, so can I just say that initially whatever the energy was, potential energy was mgh, later on it became 0, and kinetic energy was initially 0, later on it converted to half mv square. So can I say that potential energy got converted into kinetic energy, right? Potential energy got converted into kinetic energy. That is exactly we are trying to understand from this particular diagram. That means whenever an object is falling from the top to the bottom, potential energy would be mgh, kinetic energy would be 0 because velocity is 0. But when it is falling down, the final position, the potential energy is going to be mgh, and the height is 0, so potential energy will be 0 in that case. But kinetic energy would be half mv square. So what we are suggesting from this diagram is that potential energy is getting converted to kinetic energy, right? And that is according to the law of conservation of energy also. As you know, it can only be converted from one form to another. So yes, that is the same thing we are trying to discuss. Now, the another thing which you need to remember is what is mechanical energy. Mechanical energy is nothing but the combination of kinetic and potential energy. The sum of kinetic and potential energy of an object is called as total mechanical energy. Total mechanical energy. So, are you understanding this? What is mechanical energy? Mechanical energy is nothing but the sum of kinetic energy and potential energy of an object is called as mechanical energy. So, if you are trying to understand that point, that potential energy plus kinetic energy remains constant, that is the logic we are trying to understand. Okay? It remains constant, it has a constant value, it is not going to change at all. So, we have seen the definition of mechanical energy also, that it is the mechanical energy, that is EM, is equals to potential energy plus kinetic energy. Mechanical energy is equal to kinetic energy plus potential energy. Now let us talk about something called as power. So that this is the new physical quantity we are going to learn in this lesson. Rate of doing work. Let us try to understand this. What is rate of doing work? Rate of doing work is called as power. Okay, the physical quantity we are saying is the rate at which it is done. Like, I will just give an example. Suppose you are trying, suppose let's say there are lots of steps. Correct? Now, we are, suppose let's say, having one competition between you and your father. You and your father. Okay. The competition is something like this, that you have to carry some object from bottom to the top, you have to keep it at the top and come to the bottom again, right? Are you understanding the work? Matlab, what kind of competition we are playing at? So there are lots of balls what we have at the bottom, and the job is you have to take one ball, you have to run to the top, you have to keep that ball to the top and again come back. Now you tell me, out of you two, that is you and your father, who is going to be more fast? You are going to be more fast. You will be more fast. Why? Because you are having a lot of energy, and that is we need to remember this, right? So father will be able to do the work, but father is doing the work, right? Father is also doing the work. That means he is also keeping the ball from bottom to the top side. So you are doing the work, father is also doing the work, but there is a difference. The difference is you are doing the work at a faster rate. You are doing the work at faster rate, so faster work, and this is slower work. Your father is doing the work very slowly, so that is called a slower work. So what we can say is we need to differentiate between the two then, right? Faster work, there should be some way so that we can find out who is doing faster work and who is doing slower work. So for that we are having the concept called as power. So in this case we are trying to find out through power itself. So in this case you are going to say you have more power, you have more power, and your father has low power. And what does it mean? What is the meaning of power? The meaning of power is that whenever we are saying that you are having more power, it means you can do the work at a faster rate. Faster rate of work you can do. Rate is fast. Rate is fast. And the rate in this case is slow. Rate is slow. Okay, so chalo, let us try to find out the definition for power then. So they are saying power is nothing but rate of doing work. Now what is rate? Rate is nothing but any quantity divided by time. You must have, let's say, gone through this word in the lesson of motion in this particular 9th standard itself. Rate is nothing but any quantity divided by time is called as a rate. And they are saying rate of doing work. So the top part will be work itself. So power is equal to work by time. But you tell me, work is also energy. So can we say if we write down power as P, work as W, T by time. So the formula would be P is equal to W by T. But you also know that work can be represented by energy. So it can be energy by time also. So the formula becomes power is equal to work by time or energy by time. Now let us try to understand the unit of this. We have to find out unit of this. Now what is the unit of work? The unit of work is joule, and the unit of time is second. That will be same for energy also, joule per second. So basically can we say unit of power is joule per second. Joule per second. But joule per second we have a word for it, and that is also called as watt. That is also called as watt. Now you might be getting confused why to call it watt. Now for example, even in the work you had the formula as work is equal to force into displacement, correct? You had this formula, you had written work is equal to force into displacement. Now force unit is Newton, displacement unit is meter, but you decided to call it Newton. Sorry, you decided to call it joule, right? You decided to call it joule for easier, so let's say way, or to make it easier. In the same way, joule per second we have another word for it, and that is called as watt. Correct? So power is equal to work by time. What is the unit of work? Unit of work is joule, and unit of time is second. Or you can write down this as watt also. So what is the SI unit of power? Watt. So watt is the unit. Now you have to understand one thing, like you have units like kg, like you have unit like gram, then you have kg, then you have tons, then you have quintals. In the same way, there are higher units for watt also. The first higher unit is 1 kilowatt. 1 kilowatt is equal to 1000 watt. Kilo means what? 1000. So 1 kilowatt means 1000 watt. It can also be represented as 1 kW. Kilowatt can be represented as 1 kW. K small, W capital. So K small, W capital is also equals to 1000 watt. And watt can also be equals to joule per second. So that's why 1 kilowatt is either equals to 1000 joule or 1000 joule per second. So you have to understand one thing, that 1 kilowatt is either equal to 1000 joule 1000 suppose let's say watt, or it is also equal to 1000 joule per second. So out of these two, you can use any conversion depending on your need of the numerical. So according to the need, you can find out. Now there is one more concept called as average power. We already know the concept of power. What is power? Power is nothing but the rate of doing work, right? Okay, so the basically power is equal to work by time. But you have to understand one thing, that some work can be done in different intervals. It might be done at different rates. Like for example, there are different tasks in the work. So first task can be done at a faster rate, second task can be done at a slower rate, then again faster, then slower rates. So there can be, the work can be divided into number of steps. So that's why we have a concept called as average power. Same like average speed, average velocity, we have a concept called as average power. So how we can find out average power? Average power is equals to, the formula will remain same. All you have to do is you just have to add total in front of work and total in front of time. So average power is equal to total time, and above would be total work. That's it. This will be your formula. Average power is equal to total work by total time. That's it. So you can suppose let's say underline this definition, average power by dividing the total energy consumed by the total time. So it doesn't have an application as such. It is just for, that means some random steps. Suppose let's say the work is divided into number of steps. At that time you can use this formula. Now let us talk about this particular question, that is two girls, each of weight 400 Newton, climb up a rope through a height of 8 meters. We name one of the girls as A and the others as B. Girl A takes 20 seconds while B takes 50 seconds to accomplish the same task. What is the power expended by each girl? Okay, so let us try to solve this question. In the first case, this is for girl A and this is for girl B. Okay, let us calculate both of them separately. Now both of them they have a weight of 400 Newton, right? Okay, so you can just write down that as force. Force of A is equals to 400 Newton, correct? And what about the force in this case? It is also 400 Newton. Now the girl A takes how much time? Suppose let us say to complete the task, if she just takes 20 seconds. So the time required in this case was 20 seconds. What about this case? In this case, the time required was 50 seconds. Correct? 50 seconds and 20 seconds. What about the height? Both of them are, suppose let's say, going to a height of 8 meters. So height is common for both of them, that is 8 meters. Now they are asking us to find out the power. That is so simple. You can just use the formula, power is equal to what? Force work by time. Work by time. What is the formula for work? Force into displacement. But displacement can be written as height. S and H can be replaced. So force into displacement divided by time. You can put the values there and you can calculate the answer. F value is 400. Height value is 8. Time value is 20. In the same way, you can find out value for here also. That is F into H divided by time. Value of F is 400. Value of H is 8. Value of T is 50. Now calculate. 0 and 0 is cancelled. 2 ones are, 2 fours are, 4 fours are 16. So that means it is 160 watt. Correct? The answer would be 160 watt. What about this case? 0 and 0 is cancelled. 5 ones are, 5 eights are 40, 8 eights are 64. So the answer in this case would be 64 and the unit would be watt. So the answer is very much clear. For the first case, that is for A girl, the power is 160 watt, and for the B girl, it is 64 watt. Okay, we'll just check the answers. See, in the book also it is given the same thing, 160 watt and 64 watt. Correct? Now, let us go for the next question. The next question is, a boy of mass 50 kg runs a staircase of 45 steps in 9 seconds. If the height of each step is 15 centimeter, find his power, take G is equal to 10. See, if we want to find out the power, power is fine, that is work by time, that is not an issue. Time is given, I think, that is 9 seconds, so that is totally not a problem. but we have been given mass. So we have to convert work into force into displacement, right? So displacement divided by time. Do you have force? No. But then you need to convert force into mass into acceleration. So that is mass into acceleration is g in this case. So you can write down mg as divided by t. Okay. What is the value of mass? That is 50. What is the value of g? That is 10. What is the value of displacement? Displacement has to be calculated because there are 45 steps, right? And each step is of 15 centimeter. So 15 into 45 will give you the total displacement. 15 5s are 15 4s are 60. 15 5s are 75, right? Okay. So 7 carry. 15 4s are 60. 60 plus 7, that is 675. Correct? Are you understanding this? How we calculate 15 for 55, 75, 5, 7 carry, 15 for the 16 plus 67. So basically we have 675 and the unit would be meters in this case. So we have displacement, we have g value, everything. We just have to put the values. Value of t is 9 seconds. So you can put 9 there, 675. Now, you can divide by 9 itself, right? See, this calculation becomes easier if you divide 675 by 9. 9, how much are 63? 9 sevens are 63, right? 9 7, 9 6 are 54, 9 sevens are 63. And 7 minus 3, that will be 445. 9 5s are 45. So the calculation will become 75 into 10 into 50. The final calculation would be 5 into 5 is 25. 5 into 5 is 25. 5 2 carry. 5 sevens are 35. 36, 37, 37, and then 2 zeros, right? So that would be 37500. Correct? Okay. So let us check if we are getting the same thing, right? 37500. Correct? Okay. Now question is, now why we are not able to get our answer? Like, the answer is 375 matlab in the book and we are getting 37500. What is the reason? The reason is very simple, that whenever we were doing the calculation in for displacement, basically we had not converted centimeters to meters basically, and that is the reason why we are getting those two extra zeros. So you can do one thing, you can convert this, your answer is in centimeters here, you need to convert this, that is a centimeters into meters. So the answer would be 6.75 centimeters. So you can just put the decimal here, so that would be 0.75 and the answer would be 2 zeros would be cancelled. So automatically your 2 zeros are getting cancelled. So answer would be 375 and the unit would be watt. Are you understanding this? That we had multiplied 45 into 15, so the answer was in centimeters, but we didn't convert at that time, but later on we have converted, so that has become centimeters to meters now. That is 6.75 meters. Correct? Okay. Now let us move ahead. This is our calculation. Now let us talk about commercial unit of energy. What exactly is commercial unit of energy? Commercial unit of energy is nothing but, see, whenever suppose some person is asking you your weight, for example, so you generally give your weight in kgs, right? You do not give your weight in mass, like milligrams. You are not giving your weight as, suppose, let us say 49,500 milligrams or something like this. You are never talking about this, right? You are saying either it is 50 kg or something like that. You do not give in milligrams. Why? Because milligram is a very small unit for giving the answer, correct? So hence, what you are trying to do is, the unit which you are using, like joule, is very small. The unit of joule which you are using is very small. We need to use higher unit for commercial purposes. That is for some another commercial applications. So the unit we are using is, that is kilowatt hour. The unit we are using is kilowatt hour. Now, how to say that? Suppose let's say kWh is the unit of energy. Let me just show you how that is the unit of energy. So power is equals to energy by time, correct? So can I say power if I can represent this by watt, and suppose let's say time I am representing by seconds. But can I use higher units of power and time? Definitely I can use, right? Instead of watt, I am using more higher unit. Can I write down kilowatt? Instead of watt, I am using kilowatt. Can I use higher unit of second? Instead of writing down seconds, I will use hours. Right? Okay, so I am using hours in place of seconds. So can I replace, let's say, change the position of h to the other side? So this will become E is equal to E is equal to, this will become E is equal to kWh. Are you understanding this? Just transfer that H to the other side and you will get the new unit for E, that is kWh, and it is also called as kilowatt hour. Right? And how to represent this? K small, W capital, H small. That's it. So that this is called as commercial unit of energy, and this is also called as unit. It is just called as unit, or it is also called as commercial unit of energy. So what is commercial unit of energy? Energy has lot of units, but what is its commercial unit? It is kWh, that is this one. So if in the exam they are asking you what is the SI unit of energy, you are going to write down joule. If they are asking you CGS unit, you are going to write down ergs. And if they are asking you commercial unit, then you are going to write down kWh. Are you understanding this? Okay? This is how you are supposed to write down. SI unit is joule, CGS unit is erg, commercial unit is kWh. Okay. Now let us go for the next point, that is commercial unit. So that we have already seen that what is commercial unit, what it is called as, what is the name, we all that we have seen. But we want to know the relation between, see, we already have the relation between joule and ergs. What is the relation? 1 joule is equals to 10 to the power 7 ergs, right? In the same way, we also want to know the relation between joule and kWh. We want to know the relation between joule, this joule, and kWh. What is the relation? Like, what is the conversion factor? So that is so simple to calculate. See, focus on this. Can I write down 1 kWh is equal to 1 kilowatt into 1 hour? Right? I am just separating kilowatt and hour. I have separated kilowatt and hour. Can I write down kilo means 1000 basically, so that is 1000 watt into. Can I convert hour into seconds? 1 hour is how many seconds? 60 into 60 seconds, right? So basically that is 3600 seconds. 3600 seconds. Okay, now you multiply. So this will become 1000. If I suppose, let's say, multiply that 1000 with 3600, this will become 3600 and the 3 zeros of the previous ones, 8, 1, 2, 3. So this will become watt second, right? But watt second according to you is what? See, power is equal to energy by time. Correct? Power is equal to energy by time. What if what is the unit of power? That is watt. And what is the unit of time? That is second. So watt second is equals to what? Energy. That means joule basically. Correct? Energy has the unit as joule. So joule is equal to watt into seconds. So you can replace this watt second, right? This watt second is nothing but joule. So please replace it. Okay, so this will become 3, 6, 1, 2, 3, 4, 5, and the unit this time would become joule. Right? Okay. Can we write down this in the standard format? The number will be 3.6 into 10 to the power how much? I have taken the decimal point. How much time backwards? 1, 2, 3, 4, 5, 6. 6 times backwards I have taken. So this will become 3.6 into 10 to the power 6 joule. Right? Okay, so this is the relation what we have between kilowatt hour and, suppose let's say, the joule itself. So this is the relation you are looking at. 1 kWh is equal to 3.6 into 10 to the power 6 joules. Right? So you can definitely use this. And the another name for that kWh is also called as 1 unit. So you can use that also. Now let us talk about a simple question on this. A question they are asking is, an electric bulb is of 60 watts. It is used for 6 hours per day. Calculate the units of energy, that means in kWh, how much energy they have consumed in 1 day by the bulb. So you can easily calculate that. The power of the bulb would be, see, to calculate energy you will require power. Okay, the first you need to calculate the power itself. So power is given as 60 watt, that is already given. So power is equal to energy by time. What is the formula for energy then? That would be power into time. What is the value of power here? That is 60 watt. And what is the time which is given for, let's say in this case, that is 6 hours. So you can put at 6 hours here. So that will become 6 6 are 36. So that is 360. And the unit would be watt hour. But according to our information, the unit is, let's say whenever we are saying unit for energy, that is kWh we are talking about. But this is not kWh. To convert this into K, we need to divide by 1000 only, then this will become K, that is kilowatt hour. So if we divide this by 1000, this will become 0.36, right? This will become 0.36 and then it will be converted to kilowatt. So this is your answer. Understood? So we have divided it by 1000 to convert it into kilo. So it is something like this. The final answer you had received was 360 watt hour. Then you divided by 1000 and you wrote K for the top side. It got converted to kilowatt and then hour. So 0 and 0 are cancelled and 36 by 100 is 0.36. So this will become 0.36 kilowatt. So that is your final answer. So in this way, we have, so let's say, completed this topic. Now you have to do one thing. You can go through the exercise which is given at the back of the lesson, and then suppose let's say if there is something hard, you can definitely ask. You can put it in the comment section, and you can ask me the question if there are some hard questions in the exercise itself. In the textbook back point or even the index questions, if you have any problems, you can put in the comment section. I will definitely answer. So thank you so much for today. Have a nice day and please use this particular videos for your revision purpose. Subscribe to this channel. Also like this video and share this video with lots of your friends who are from your class, and please subscribe to this channel. Thank you so much. Bye bye.